Welcome, human, to UnityQuickTips tutorials. So this episode we're going to be going over the basics of raycasting. So raycasting is basically kind of like shooting a virtual laser pointer in 3D space and just seeing where it lands. And we can use that to do a lot of cool tricks in Unity 3D. For example, I have this kind of cube with a sphere attached to it, and when I click, I shoot a raycast from the point of this kind of cube that's supposed to represent like a gun or a flashlight or a laser pointer or just something, whatever. Just basically just making a cube move around the level and just land on whatever I want to put it on. So that is what we're going to be learning how to do in this episode, and we're going to be going over how to do that mainly in JavaScript, but I'm also going to show you the syntax of it in C#, but the basic ideas are going to be the same in both JavaScript and C#. Another thing I should mention is that I'm actually going to be doing about 3 more raycasting tutorials after this that just kind of keep on getting more and more advanced. So this is the first one, so this one will be the most basic, and they will just keep going more advanced from there. And I'm going to put a link in the description below to all of those other raycasting tutorials in case you are interested in those. So let's go ahead and jump into script and take a look at what we're going to be doing today. So where are we? So the 2 scripts we have are raycast cube C and raycast cube J. So it's just raycasting and making a cube stick to a surface that we raycast, and one says J and one says C because one is JavaScript and the other is C#. So why don't I pull up MonoDevelop so that we can actually take a look at these scripts. So this is the JavaScript one, and this is the C# one. So as you can see, they look really similar. It's just one has slightly different syntax than the other. And then also there are a bunch of lines of code that are commented out, and what we're going to be doing is actually commenting and uncommenting out lines of code to show all of the different, well, not all of the different ways of raycasting, but we're going to go over some basic ones. So the first one we are actually going to go over is just shooting a raycast, and it's basically just a yes or no raycast. We're not going to gather any information from it. We're basically just going to shoot a raycast, and if it hits anything, we're going to print a message in the console that says either yes or no. And what I mean by the console is the bottom of Unity that's actually behind me. So if I if I go to Window and then I go to Console, basically this window up here, we're going to print a message yes or no whether or not we get a raycast. Before we jump into it, why don't we go ahead and take a look at our surroundings, basically. So I have a first-person controller with a camera on it, and this is from the FPS1 tutorials. And the game object that is actually going to be doing the raycasting and has all of the raycasting scripts attached to it is this one that I'm calling Raycaster. And one other thing you'll notice is that I'm only going to have one of these checked at a time, and in this case I'm just going to have the JavaScript one checked for this particular episode, and the rest of these I'm going to be going over in later UnityQuickTips episodes. Once again, link in the description below to those later episodes. So yes, what is next? And then there is the raycast cube, which is this little thing right here, which is the thing that you saw flying around, sticking to different pieces of surface areas or surfaces in the level. And then I just put a little sphere child to it, just so that we can actually visualize what is the normal of each face that we actually hit, and that's another piece of information that we can get from raycasts. So for things like bullet holes or blood spatters or things like that you actually want to stick to a surface of an object, depending on how that object is rotated and how that particular face that you raycast, that the raycast actually hit, is rotated and facing in 3D space. And one other thing is that neither of these two have colliders. I removed the collider component because the collider is what the raycast will actually check for when raycasting. So if you don't want something, like if you have a raycast that's just raycasting for everything in your level, regardless of tag or layer or anything like that, then you need to make sure you want to take the colliders off of anything that you don't want to get hit by a raycast, because that can kind of make things get a little bit screwed up and weird, and your raycast will just be all wrong and you'll be detecting all of the wrong things. So just be wary of where your colliders are. Another trick, if you don't want a game object to be detected by a raycast, is under layer, you can just go to ignore raycast and just set to that layer. And in this case, I would just write yes, change children, so these two game objects will not get detected by a raycast. But they weren't going to get detected by a raycast anyways because they didn't have colliders. But if they did have colliders, then it wouldn't be an issue anymore. So yes, that is just a cool little trick for you people there. Yes, anyways. So let's move on, and actually let's talk about the code now and how the code is actually going to work. So we have a couple of variables that we want to have in the inspector, and the first one up here is cube, and this is going to be a transform, and this is just the transform of the cube that we actually want to stick to the surfaces to represent where we are raycasting and where our raycasts actually hit. So we'll just change the position and rotation of that transform, and all we have to do in our script, let me select the Raycaster script. Normally, when you first put this script on a game object, it will say none. And then all you have to do is drag and drop this game object here, and then it will save its transform in the cube variable like that. And then the next variable is Cast Dist. So this variable we're not actually going to be using all the time. It's going to depend on which of these lines down here. By the way, these are all of the commented out lines of code are the actual raycasting lines of code. So depending on which one we uncomment and actually activate, we might use the Cast Dist variable to actually limit how far that raycast will actually raycast out, so that let's say we have a bullet and we only want it to raycast like 5 feet in front of it because it's moving really, really fast, but it's not moving instantaneously. So we would set it to have a unit of 5, or depending on what the units in your scene are, because I think the units in Unity are pretty much automatically meters. So that would be what? 1.6 meters approximately would be 5 feet. So anyway, so that's basically just the distance at which the raycast is going to raycast. The next variable is a string, and it is called tag check. So another thing you can do with raycast is you can actually check the tag of the game object that you raycasted to see if it is a game object that you actually want to be raycasting for. But just be mindful, in this particular episode we're just going over plain old raycasts, which only raycast once, and it will just return you the first object that it finds. In a later episode we're going to be going over raycast all. And raycast all is actually going to raycast and return you all of the colliders that you actually hit. So if we raycast against a game object and it doesn't have the tag that we're looking for, we have to raycast again before we can actually check to see if it's the right tag. So it's just going to return us the first one that it finds for this particular tutorial. If you want it to return you everything, that is going to be a later episode. And then we have another variable called that is a boolean, so a true or false variable called check all tags. And check all tags, if it's true, it just means that it's going to not look for whether or not we found the tag that we're looking for. So if we check this to true, basically this variable right here becomes irrelevant, and we don't actually need to put in a tag string in there anymore, and it will just check for every single tag that is in the scene. Well, actually, it isn't technically checking for every single tag, it's just not checking at all, and it doesn't care about tags anymore. And then let's go over the function update loop, which is all of this right here. So the first thing that we do, and remember the function oops, I bumped the microphone. The function update loop loops every single frame, so this is going to happen every single frame. So we're declaring a variable called found hit, and this is a boolean, and we're setting it to false. So we're declaring it on the first frame in the function update loop. Every time after the first frame, it's just going to reset this variable because we have the equals false on the end right here. So basically at the beginning of every frame, found hit is going to equal false. And then we're setting another variable, hit, and is just going to be of type raycast hit. And a raycast hit variable is a variable type that you can save for variables, and it will save you a bunch of cool information about raycasts. And actually, why don't I go into the Unity scripting reference and we will take a look at a raycast hit. Actually, one second, I just gotta find, where is it? All right, here we go. Raycast hit. So this is the Unity scripting reference for a raycast hit variable. So we get a bunch of bits of cool information, and I think the two most common, or two or three or four most common that you'll probably use are point, normal, rigid body, and transform. Distance is also pretty cool. Collider is also pretty cool, and there's a bunch of stuff. So let's start with point. Point is the point in 3D space that the raycast actually hits something. So no matter what we hit, it's just going to take that exact point. So basically, if we have a laser pointer and we're shooting that laser pointer, where the red dot shows up in 3D space in X, Y, and Z is going to be the variable point, so we can find out where our raycast hits that way. So in our script, we're actually going to take our cube that we're moving around for the raycast, and we're just going to do transform.position equal point, basically. Not exactly like that, but that's the basic idea of how we're going to position the cube in 3D space. Next is normal. Whoops, I didn't really mean to click on that, but that's okay. So normal is a vector3 variable, so it's a directional vector3 with a magnitude of 1. So what that means is that basically if you imagine a vector3, and so here's point 0, 0, 0, and then let's say we're looking at 1, 0, 0. So here's 0, 0, 0, and 1, 0, 0. Wait, yeah, 1, 0, 0. So that's 1 to the right. So that basically now that vector3 is pointing to the right, and it has a magnitude of 1 because it's only 1 long. So I always like to try to imagine magnitude vectors as kind of like, you just imagine how the numbers would create an arrow and where that arrow would be pointing to get a direction. Now, the direction that we're actually getting for the value normal, or the variable that we're getting from the variable raycast hit normal, what that is basically the direction at which the face is facing that we actually raycast it against. So let's see, let's say, let me take this notepad and hold it kind of at an angle. So let's say we're raycasting this way and we hit right here. So where my fingertip touches the paper, that is the point. And then the normal is going to be a vector3 that represents this direction. Well, actually more outwards from the paper, but it's going to be pointing in the exact direction of the face that we hit. Or actually, you know how 3D models are technically made up of a bunch of just triangles put together in 3D space. Just imagine that triangle. I'm going to just imagine my hand's a triangle. It doesn't look anything like a triangle, but the normal is that. It's pointing away from the triangle and the direction that that triangle is facing. So that is the normal. Hopefully that made sense. The next is rigid body, and this is pretty simple. It's just the rigid body component that the game object that so we raycast, we hit a collider. That collider is on a game object, and when we write raycast hit or whatever the variable that we have in our case, as you can see above my head, we named it hits. If we do hit dot rigid body, it's going to return us the rigid body that is attached to the game object that we raycasted. Same with transform. It will just return us the transform of the game object that we raycasted. And then distance will give us back the distance at which we actually raycasted against. So basically, if you have a laser pointer and you shoot that laser pointer, and then you take a measuring tape and you measure between your hand and where the dot lands in 3D space, and you just measure that distance, that is what distance will give you. Okay, so that is a raycast hit variable, and that is something that you can get back from a raycast, which actually I kind of went out of order for this particular tutorial because we're actually not going to be using those until down here. But before we, I guess it made sense that I actually explained all of that. So now that you know what a raycast hit is, we're going to quickly show how to do a raycast that doesn't actually use a raycast hit variable. So something that we don't get any information back from, except for a print message in the console that says, yes, raycast detected, or no raycast hit detected. Actually, I should put the word raycast hit, not detected, like that. All right. So basically, we're just putting physics.raycast, transform.position, and transform.forward inside of an if statement. So that's a cool thing about raycast. When you're doing a raycast and you're actually calling a raycast, you can actually call it from inside of an if statement, and inside of that if statement, it will just return true if the raycast hits something, and it returns false if it doesn't. So as you can see, I have if it does return true, so if physics.raycast transform.position transform.forward. So if we get that raycast, then we are going to print yes raycast hit detected, and then else, so if we don't find a raycast, we're going to print no raycast hit not detected. So let me quickly break down the physics.raycast. So we have physics. It is capitalized because we are just calling it from, I guess, basically the physics engine, or we're just calling it from Unity. We're not calling it from any particular game object. We're just calling it out of physics in general. So that is why it is capitalized. And then we have raycast, and raycast is capitalized because this is an action. It's a function, so we capitalize it. And then inside of the parentheses, we can give it two things. Actually, it's really flexible what you can put inside of a raycast function, but in this particular case, we are only giving it two things, an origin and a direction. So the origin, transform.position, is basically where our hand would be if it was holding a laser pointer. This is where the raycast is actually going to start. And then we have transform.forward, and this is our direction. So transform.forward is also a magnitude vector, or a directional vector, with a magnitude of 1 that's pointing in the direction that is forward for this particular game object. So basically, if we have a game object and it's facing this way, forward is this way, obviously, and it's just going to give us back the numbers that are going to represent that direction. So imagine like the tip of my nose is 0, 0, 0, and then forward is some numbers. Oops, I keep bumping the microphone. Sorry about that. Forward is this way, and then whatever these numbers, what they will end up being. So basically, it's kind of a line in 3D space that represents a direction, and it is going to have a magnitude of 1. So then from within inside of that if statement, it casts a ray, and it is going to tell us whether or not we actually hit anything with our raycast. So let's go ahead and give it a quick test. So if I hold down the mouse, that was one thing I should have also mentioned, is that I put all of this inside of an if statement that says if get button fire 1. So I'm only going to be raycasting when I'm holding down left mouse button. So just wanted to quickly point that out. And actually, I'm going to move Unity over a bit just so that you can see the console behind me. So you see it says no raycast hit not detected when I point it at the sky. And then when I point it at the floor, it says yes, raycast hit detected. So that is basically how that is going to work. And then let me go back here and let me show you one other cool thing you can do. So I'm going to comment this out one more time. Oops. /**/. Okay, so we commented out that paragraph. And let's comment or recomment back in or uncomment this little chunk of code. So this is pretty much the exact same thing as you see up here, except we have one more thing. So we have transform.position, our origin, and then we have transform.forward, our direction, and then we have raycast dist, which is this variable up here. And basically, if we add that inside of the function, it's just limiting how far our raycast can actually go and how far it will actually look for collisions. So let's go ahead and demonstrate that. I'm actually going to go to the raycaster and change raycast dist to something smaller like 25. And then let me move this back over again so that you can see it. All right. So if I walk up to this wall, it says, yes, raycast hit detected. And then as I move back, it should say, no, raycast hit not detected. Even though I'm clearly still pointing at it, I'm just more than 25 units away from it because that's what I set that variable to. So now it's just limited and we can't see raycasts forever. It will only go for whatever distance we actually specify it to. So that is basically a yes or no raycast that doesn't return us any information. It just returns us true or false. So if we actually want to get some information back from a raycast, we are going to do it with these two lines of code down here. And actually, I'm also going, why can't I just, all right, let me /*/ whoops, there we go. And then let me also explain these lines of code down here. So like I said earlier, actually let me uncomment out this line of code. I'm going to explain multiple lines of code at once to make it all work together. So this is raycast infinity distance. So basically this is going to be a raycast that is going to return us information, and this raycast is going to have a distance of infinity, and it's just going to go forever. Basically we're not going to specify a distance, so it's by default going to be infinity, so that this raycast just goes on forever and raycasts forever. We don't have to worry about a distance for this one. And then remember I said a physics.raycast function returns a true or false variable. That's what we're using it for right here. We have found hit equals, and remember found hit is this variable up here that we keep on resetting back to false at the beginning of every frame. So found hit equals raycast transform.position, transform.forward, and hit. And remember, hit is this raycast hit variable up here that we declared. So this is where we're going to be saving the raycast hit information. And just to make sure, the raycast hit variable is this right here. So it's all of this information that we're saving inside of the raycast hit. So when we do this right here, physics.raycast, and all of this right here, we're shooting a raycast, and if that raycast actually detects something, it's going to return true, and it's going to save a bunch of information in the raycast hit variable hit. So when it returns true, we can save it inside of a variable, as you can see here, and we're saving it inside of the variable found hit, so we can detect whether or not we actually found a raycast hit, so that we know whether or not to actually change the position of the cube. And that is this line of code. Actually, let me scroll down so you can see it. This couple of lines of code right here. This is just if found hit. So if found hit is true, it's going to return, or it's going to execute these two lines of code. And the first line of code is cube.position equal hit.point. So remember, cube is the transform of the cube that we actually want to move around in our scene, and position is just where it is in 3D space. And then we're going to set it to equals hit.point. So remember, hit, as we set it up here and declared it up here, is saving a bunch of information about the raycast that we just shot. And hit.point is the point at which it is in 3D space. So when we set cube.position to hit.point, we're just moving that cube to where that raycast actually hit something. And then very simply, we have cube.rotation equal quaternion.lookRotation hit.normal. So cube.rotation is obviously the rotation of the cube, and then we're going to set it to quaternion.lookRotation. Now the reason why we're doing that is because cube.rotation is of type quaternion, so it's a rotation in 3D space. And then hit.normal is a vector 3. So we need to convert this vector 3 to a quaternion, and we're going to use the function lookRotation from the quaternion class to do that. So when we do quaternion.lookRotation, you give quaternion.lookRotation a vector 3, and then it is going to give you back a quaternion that roughly, besides this kind of tilt, is just going to tilt it according to world up, but that's just extra detail that you don't need to worry about in case you don't know what that means. But it's basically going to turn a vector 3 into a quaternion. Just note that it has to be a vector 3 that actually represents a direction. I mean, it doesn't have to be, but to make things work, that's basically what it is doing. So any kind of vector 3 that represents a direction, it converts it into a quaternion. Okay, so that's what happens if we actually find a hit. And then let's explain this right here. So if found hits and check all tags equals false. So remember up here, check all tags is a variable that we can check true or false to determine whether or not we are actually going to bother checking for tags in case we only want to check for a very particular type of game object, or in case we want to check for just every single game object with a collider in the scene. So we have if found hit, so we're only going to actually check for this information if we actually found a hit according to this raycast up here where we have found hit equals and then the raycast function. So if we did find a hit and if check all tags is false, so if it's false, that means we are checking for a very specific tag, and to check for that very specific tag, we're going to do this right here. So hit, so remember this is the raycast hit variable, dot transform. So whoops, actually I want to pull up Chrome so I can show you this. So raycast hit dot transform, and then if we open up transform, actually go into here, we can see that, where is it? It's somewhere in here. Tag, maybe it's an inherited variable. There it is. Yeah, inherited variable. So a tag is a bit of information that is saved inside of the transform class, and we're getting the transform from the raycast hit. So that's why we're doing hit.transform.tag. So hit.transform.tag is a string of the tag of the game object that we raycasted. And then we're going to say if it does not equal tag check. So remember, tag check is this string up here. And we have it by default set to level parts, but you can set it to whatever string you want in the inspector. So if it isn't, or if the game object does not have, so exclamation mark equals does not equal, if the game object that we just raycasted does not have the tag that we're looking for, then we're going to set found hit to false. So basically, if we did find a hit and then we don't have, and that game object that we raycasted does not have the tag we're looking for, we're just going to set found hit back to false. So that way this right here, this line of code does not execute, and it's as if we never found a raycast hit in the first place. So I guess let's go ahead and give that a test run and see what that looks like. So we are going to raycast against only something with the tag of level parts, and actually I'll show you real quick, like the floor has a tag of level parts, this wall has a tag of level parts, so just showing you where the tag is. And then the cube is actually rotated according to the normal of the face that we actually hit. So as you can see, it kind of like it rotates around onto everything and it just sticks to the surface and it's moving around. And actually these game objects right here don't have the tag of level parts. So if I walk up to them, it's not sticking to those at all. It's just going through them, and if that's the raycast it actually finds, then the cube just stays where it is until we do find a raycast hit that does have a tag of level parts. Okay, and let me go ahead and find the raycaster and then select check all tags. That way we can stick it to these game objects here because we're no longer checking for tags, we're just checking for raycast hits in general. So anything that has a collider we are now colliding with. And one thing I want to quickly point out is that that does include triggers. So if I walk up this staircase right here, there are actually two invisible triggers that I can walk through that make sure that my rigid body character does not just ramp off those stairs. So if I shoot this cube right here, I can actually make it float on something. It appears to be floating, but it is actually raycasting a trigger game object. So basically it's a collider that I can walk through, but raycasts will still raycast against it. Okay, so that is how to do that with an unlimited dist. And then the only thing that we have left to do is to do an infinity distance. So that is this line of code here. We're just doing found hit equals physics.raycast transform.position transform.forward hit raycast distance. So basically exactly the same as this line of code up here, except for we're just adding raycast dist to the end of it to actually limit the distance at which it will actually check for raycasts. So we have the origin, the direction, the raycast hit variable that we're saving all of our information inside of, and then the limitation on the distance of the raycast. So when I run our game now, you will see that I can raycast, and then past a certain point, there's a trigger there. Past a certain point, it will stop raycasting. So I'm going to raycast on this wall, and then as you can see, I can move it. If I back up, now I can no longer touch the wall because I have a limitation on the distance of my raycast. So that is pretty much everything you need to know about the basics of basic raycasting. Real quick, I'm just going to jump inside of the C# script and show you the only differences. The only differences are, well, basic C#, all of that, using Unity Engine, using system.collections, and all of that stuff. And we're declaring all of our variables in here. They're all the same variables. They're just with the syntax of C#, public, transform, cube, all that kind of stuff. We got to put the F after 100 here to declare that it is a float. And then let's see what else is different. The raycast hit variable that we're declaring, we can't just leave it empty with nothing. We actually have to assign it to something. So we're doing a new raycast hit. So make sure you remember the opening and closing parentheses just to declare that we are creating a new empty raycast hit variable and saving it inside of the variable raycast hit, so that later on when we do want to save information inside of there, it actually knows the variable type that we're saving information inside of. So all of this is exactly the same. So those yes or no raycasts are exactly the same in C#. And then the only thing that is different is down here with the hit variable. So before we would just write hit. In C#, it is required to write out. So basically that means we are sending information out into the variable hit, which is of type raycast hit. So you just got to make sure you put that out in front of hit, basically. And then besides that, everything else is basically exactly the same. So that is just quickly going over the syntax of how to do that all in C#. So I'm going to kind of try to scroll just in case you want to read that. So you can like pause the video, just making sure that's available. I'll probably also just put it on MediaFire so that you can download it. But just in case you can't get that file, just so that you can read it. Okay, that should be good enough by now. All right, so that is how to do raycasts. So I'm going to be doing other videos on how to do raycasts, and I'm going to be getting more advanced. So I hope you I lost my train of thought because I'm multitasking. Okay, I hope you enjoyed this episode. So until next time, I will see you later and keep making games.